In today's iLearn review video, we're going to focus on taking a look at order of operations, placing numbers from least to greatest when they're written in different forms, and then also determining whether or not something is rational, irrational, whether it has a repeating decimal, non-repeating decimal, or if it has a terminating decimal. So the first thing we're going to look at is order of operations. And so you really need to remember that order of operations is PEMDAS. So parentheses, exponents, multiplication and division, addition, subtraction. And you notice I kind of wrote it funny. A lot of people write it just the PEMDAS, but I put M and D on the same line and A and S on the same line. The reason for that is multiplication and division are equal to each other. You do whichever one comes first from left to right. And the same is true for addition and subtraction. You do whichever one comes first from left to right. So the P stands for parentheses, the E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, S stands for subtraction. Again, multiplication and division are equal to each other. You do whichever one comes first from left to right. Addition and subtraction are equal to each other. You do whichever one comes first from left to right. So as we move to our first problem, it should be number 12 on your worksheet. We're going to think about those order of operations. So for this problem, the first thing would be exponent. There are no parentheses, so we skip that step. So 6 times 6 is 36. Everything else just drops straight down. And typically you don't use a calculator for order of operations. This is to see how you do, because the calculator already knows the order of operations. So usually you go step by step and do them. So again, working left to right, because we only have subtraction and addition left. And remember, they're equal to each other, so you do whichever one comes first from left to right. So the first thing I'm going to do is 36 minus 4, I'll get 32. I can bring down the plus 2, bring down the plus 4. The next thing I'm going to do is 32 plus 2, and I'm going to get 34. Plus 4 again, I'm going to do that, just that part, and I get 34 plus 4 is 38. Again, this is order of operations. You follow the order of operations. Looking at number 13, you can see that there are no parentheses in this problem again. So the first thing we're going to do is focus on the exponent. So 3 cubed is 27. 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. Bring down the 2 and the plus sign. Minus 2 also comes down. The next thing you should do is add 2 and 27 together. You're going to get 29. Minus 2 comes down, minus 2 comes down. Again, we're going left to right, so 29 minus 2 is 27. And then bring down the minus 2. We finish with doing 27 minus 2, which is 25. Moving on to problem number 14. In this problem, we do have a set of parentheses. We're going to focus on those first. So 3 plus 1 is 4. Bring down your minus sign, the 2, the minus sign, the 4, the plus sign, and the 3. And then we have addition and subtraction left, so we work left to right. 3 plus 4 is 7. Minus 2 comes down, minus 4 comes down. 7 minus 2 is 5. Minus 4 comes down. 5 minus 4 is 1. One thing that you might consider is combining some of these steps. You don't necessarily have to do them step by step. You can, because we can see that 3 plus 4 is 7, 7 minus 2 is 5, 5 minus 4 is 1. So you don't have to break them apart like that. Moving on to problem 15. Again, order of operations say to do parentheses first. There's 2 sets of parentheses here, so you do the inner set of parentheses first. 3 plus 6 is 9, plus 3 more is 12. And then we've got times 2 and the outer parentheses left. So we bring down the times 2, we bring down the division sign and the 6 and the parentheses. 12 times 2 is 24. divide 6 drops down. 24 divided by 6 is 4. The next step that we've got to do is we've got to go over to, we want to place numbers from least to greatest. And to be honest with you, the only way to do this is to convert them all to the same thing. So either make them all fractions or make them all decimals. 90% of the time it is usually easier to make something all decimals. We know that pi can be estimated as 3.14. 2/3, if you're not sure, you can always use a calculator. You'll find that 2 divided by 3 is 0.666 repeating. So we'll just prove that real quick. And we got 2.66. We only need to have the hundreds placed for right now, so we'll just do 0.66. The square root of 17, again, I don't know what that is. You can use a calculator. So square root of 17, 4.12. 4.12. 3.5 is already written as a decimal. 15 divided by 7, we can again use a calculator. So 15 divided by 7, 2.14. And then we just go through and we place them in order. So it looks like 0.66 is the lowest. The next lowest would be 2.14. The next lowest after that would be pi at 3.14. And then we have 3.5 that would be lower, the next lowest. And then finally we have 4.12. Now this is the important part. While we switch them all to decimals, the actual question said this compared to this. So you have to rewrite this in order, but you have to use what they were originally written as. So 2/3 is first. And then next second was 15 over 17. Or I'm sorry, 15 over 7. And then next was pi. Next after that was 3.5. And then finally we have the square root of 17. Again, and this would be your final answer. Usually these questions are asked in like a multiple choice type setting, but you can always place them just like I did. So looking at this one, we've got 7/2, which I know is 3.5. Again, you're more than welcome to use the calculator. 1.4 is just going to stay 1.4. The square root of 9 is 3. I don't know what the square root of 23 is, so we'll check that real quick. Square root of 23 is 4.795, so we'll round that to 4.8. So this is going to be 4.8. And then 43 divided by 21, we can do that real quick. 43 divided by 21, we get 2.05. 2.05. And then I just go through and try to list them from least to greatest. So I know that this is the smallest. The second smallest then would be 2.05. 3 would be the third smallest. 3.5 would be the fourth smallest. 4.8 would be the fifth smallest. And then go back through and do the same thing we did on the previous problem. List them from least to greatest. So 1.4 stays 1.4. The second one was 43 over 21. The next one is the square root of 9. The next one after that is 7 divided by 2, or 7/2. And then the next one after that is the square root of 23. Again, this is your final answer. And we move on to the next questions. Now for this next part of this video, we want to determine, is something a rational or irrational number? Does it repeat? Does it not repeat? So first things first, what is a irrational number? An irrational number is a number that never ends and never repeats. So irrational is it never ends and never repeats. You also can't write it as a fraction. So then rational would be any number that ends or repeats. It doesn't have to do both. If it does one, it is rational. All rational numbers can be written as fractions. Okay, so pi is the most famous irrational number. So we know that it never ends and it never repeats. So we just said that it never ends and it never repeats. So it doesn't terminate. It doesn't repeat, which means that it has to be non-repeating. Looking at number 19, we got 2/9. And so here's what I know about 2/9 is that it's 0.22222 repeating forever. And so if you're not sure, you can always use a calculator. 2 divided by 9 ends up being 22222 forever. And so once you know that, you can say, okay, well, we definitely know that it repeats. And because it repeats, that automatically makes it a rational number. I also said all fractions were rational numbers, so we know right away it's a rational number. The square root of 24 is irrational. I know that because all square roots that do not come out to be a perfect whole number, for example, the square root of 9 is equal to 3. It's a whole number. This is rational. So we're looking for irrational. So this is going to tell you that this is irrational. And interesting enough, the definition of irrational is numbers that never repeat, so it can't repeat, and it doesn't end. So it can't be rational if it's irrational, so then it non-repeating. Has to be that one. Number 21, we have 5/2, which I know equals 2.5. So first of all, we know that it is rational because it ends. And then the word terminating means to end. The next video that we will do will focus on solving equations, particularly 1- and 2-step equations, moving on to multi-step equations. So much so that we have distributive property, collecting like terms, and inverse operations. And so there will be some that will have infinite solutions, no solutions, and just one solution. So on day 3 of iLearn review, we will focus on solving equations.